Hello guys, welcome sa subject natin, and for today we will be just continuing our discussion with the analysis of our determinate team. So last time we have already identified how to calculate yung support reactions natin. Now we will extend our lesson with how to identify yung internal forces natin dun sa beam natin. So when we say internal forces, ano ba yung ibig sabihin niya? Okay? So this particular session is focused on identifying yung internal forces na tinatawag natin. Right? So for this session, the outline of the study will be as follows. We have the internal forces and beams, sign convention, procedure for solving, and of course, solve some examples in order for us to be familiar with the said method. And then learning outcomes natin for this one is to describe what are the different internal loadings present in a structural member, and also to solve for the internal loadings in a specified or designated point dun sa problem natin. Right? So let's start. Okay, so internal forces and beams. So internal forces are the forces and couples exerted on a member or by a proportion of the structure by the rest of the structure. Meaning, these forces are developed within the structure. So, ibig sabihin siya yung reaction structure once a external load o yung mga dead load, live load, and external loadings natin are applied mismo dun sa mismong structure natin. So, kaya pag dito makikita niyo dito sa photo, if you cut the section along the beam, then in-expose natin, no? In-imagine natin na ma-expose yung left side and right section, we will see forces na lumalabas dun sa cut section natin. Those forces are our internal forces na tinatawag. Okay? So internal forces natin always occur equal but opposite in pairs, no? Because each member portion nag-exert siya ng back dun sa rest ng structure natin. Kasi nga, siya ay within lang ng structure natin. So yung goal niya is to equalize or to stay yung mismong structure natin in equilibrium na fina-follow niya yung Newton's third law of motion na yung opposite but um, yung reaction natin is equal but opposite in value. Okay? And then, when a beam is subjected to a transverse loading, three possible internal forces are developed. So ito na, papangalanan na natin yung mismong forces na tinutukoy natin as internal forces. These are the normal or axial force, the shearing force, and the bending force. So the normal force is designated as N, meaning siya yung algebraic sum of the axial forces. So kung ito yung member natin, ito yung beam member natin, ang axial niya is along dun sa length niya. Kaya siya axial force, ito yan. So, ibig sabihin, lahat nung sum nung axial forces natin, kapag nag-cut tayo ng section and expose natin yung internal loadings niya, magiging siyang yung normal force natin. Okay? The next, we have yung shearing force o yung algebraic sum naman ng transverse forces natin. So, vertical forces natin. Transverse kasi yung ating section ay longitudinal in section or in size, no? Kaya transverse, ibig sabihin, ah kung ito yung longitudinal natin, ang transverse niya, yung perpendicular na na direction niya is yung transverse direction niya. Okay? Kaya nakandito yung vertical force natin. Okay? Then for the bending moment, siya naman daw yung algebraic sum nung forces moment natin. So um, yung shear at yung normal force natin o yung mga reaction and applied loads natin, once we take the summation of moment dun sa cut section natin, yun yung magiging reaction nung section na yon dun sa mga forces na yon. And yun yung tawag nating bending moment. Okay? So, in consideration itong mga internal forces natin, we follow certain sign convention. Okay? So, this particular sign convention na di-discuss ko is the one usually used in practice. Okay? So, although hindi siya yung universal rule, pero ito yung most common use na sign convention. Okay? So, let's start first with the actual force N. Okay? We say that the actual force N is regarded as positive if it tends to tear the member. Okay? So the section under consideration. So such force is regarded as tensile while the member is said to be subjected to axial tension. So kung gusto natin is um, banatin, no? Yung mismong member natin hanggang mag-tear siya, no? Or mag-break siya, ang tawag natin sa kanya is tensile force or axial tensile force. Okay? And then yung member natin, ang tawag sa kanya, subjected siya sa axial tension, which is yung force nga natin na axial force. Then on the other hand, an axial force is considered negative if it tends to crush the member. So, sabihin, pag i-crush yung member, ibig sabihin yung direction ng force natin is towards ng member natin. So, ang tendency niya is to compress, okay, yung member. Kaya such force is regarded as compressive while the member is said to be in axial compression. So in figure, ito yung figure niya, no? So kapag tensile or axial, tensile yung ating axial force, away siya dun sa member natin, ito yung cut section natin. Okay? Bawa, ito yung beam natin. Tapos nag-cut tayo. Itong cut portion na to, ito yan. Okay? And then yung kanyang may expose sa internal loading, assume siya yung positive direction niya is lagging away. So, ibig sabihin, yung assumption lagi natin sa kanya kapag ina-analyze natin yung cut section, laging tensile para positive lagi yung sense. Okay? Then, once na halimbawa maging sa upon calculation, maging negative yung value niya, tsaka natin siya i-change into compressive. Okay? So, that's for axial. And we have shear. Shear force V tends to move the left of the section upward or the right side of the section downward. So, dito nangyayari, again, ito yung beam natin. Nag-cut tayo ng section. Imagine ko, ito yung kukunin kong section. Ito yon. Okay? So, yung sa first, ano niya, tends to move the left section upward. So, ito, upward. And the right side section downward. Kaya ito, downward yung picture niya dito. Yun daw yung positive sets. Okay? O kaya pag halimbawa naman daw, yung left side ng section natin yung i-consider natin. Kung halimbawa ito yung section na yun. Okay? Tends to move the left side of the section. Okay? Upward. Kaya ito upward. And then negative naman daw ito. Yung right side natin upward. Okay? So, ito naman yung condition natin. So, para mas madaling tandaan, yung sa positive shear, yung positive sense natin, halimbawa, nag-cut tayo ng section, ang tatandaan na lang natin, yung direction is kailangan laging clockwise siya. So, ibig sabihin, kapag nag-cut tayo ng section, so, halimbawa, ito, meron tayong beam, no? Nag-cut tayo ng section. So, ito yung section na yon. Itong exposed section natin, sorry. Ayan. So, 'di ba, yung assumption natin for axial is away para positive. Sa kanya, para mag-cause siya ng clockwise rotation, kailangan pa-downward yung assumption natin. Okay? Which conforms dun dito. Okay? So, dapat yung mag-cause ng clockwise na rotation. Okay? So, yun yung positive shear natin. Then, for moment, ang kailangan naman natin is dapat yung tendency niya is mag-cause ng concavity upward kapag positive siya, sagging, and then negative naman siya kapag hugging naman siya. So, ano ibig sabihin nun? Kung halimbawa ito, apply tayo ng moment, ang sagging itsura is pag ganyan, nagsasag siya. Okay? And then yung hugging naman, edi nagkakameron tayo ng clip. Okay? So, baliktad naman. Kaya, ang consideration naman, kung halimbawa nag-cut tayo ng section, dapat yung tendency natin is magsag siya. Kaya ito, pag kinat natin yung section, ito yung direction niya, counterclockwise, kasi pag minove niya ng pagganto, mangyayari doon sa system natin, sa member natin is magaganyan. Okay? So, magsasag siya. So, kailangan sagging lagi para positive. Okay? So, in summary, again, para makonsider natin na nasa positive sense lahat ng cut section natin. So, again, halimbawa, ito yung cut section natin doon sa previous slide. Ngayon, ang magiging direction natin, ito yung positive ng N. Okay? And then, ito yung gusto natin yung sa shear, di ba? Mag-clockwise. Okay? Clockwise yung direction. So, dapat tayo ay downward ang shear. And then, ang moment natin, kailangan mag-tend na itong member natin na to is ano siya, mag, mag-deflect siya ng magsasag siya. Okay? So, kailangan magganon siya. Okay? So, kailangan yung direction natin for positive will be counterclockwise. Okay? O itaten niyang magka meron ng gantong curvature yung mismong ano natin. Okay? So, ayan yung sign convention na gagamitin natin. Right? Then now, we go to sa procedure for computation ng internal forces natin. So, ito daw yun. First is draw natin yung free body diagram. Marunong na tayo niyan. Number 2, check natin yung stability and determinancy of the structure. So, marunong din tayo niyan. And sabi ko nga nung last session natin, we can only use the equilibrium equation once our structure is statically determinate. Okay? Pag statically indeterminate siya, we need additional equation like the compatibility equation to solve for the reactions. Pero we will not discuss it yet. Okay? So, if ever we have proven na statically determined in structure, we now proceed dun sa third step, determining natin yung unknown reactions and support reactions, which already discussed na sa inyo. Ngayon, doon lang tayo sa 4, 5, 6. Okay? So, number 4, sabi niya, pass an imaginary section perpendicular to the neutral axis. Okay? Kung ito yung beam natin, ang neutral axis niya is assumed dun sa gitna niya kung rectangular siya. Okay? And then kung magpapass tayo doon ng perpendicular imaginary section. So kung yan yung beam natin, again, yung perpendicular natin na section is ito. Okay? And then, the pass section divides the structure into 2 parts. No? Pwede natin consider either part. Later, papakita ko na any portion of the beam or any part ng cut section natin, mapa left or right side yung consider natin, dapat ang makuha nating value ng internal force are the same or equal. Okay? And then for axial force computation, determine the summation of axial forces. And then for shearing and bending moment, kailangan lang natin i-write yung mga expression, yung internal forces direction natin, and then yung mga applied reactions natin. Okay? So to better appreciate this, let's go to our previous example and identify yung internal forces nung certain point. Okay? So let's have our first one. So again, i-skip na natin yung first 3 parts, no? Yung drawing ng free body diagram, identifying kung ano siya, statically determinate, and then yung pagkuha ng kanyang support reactions. Kaya nandito, i-revisit nyo na lang yung previous lecture. Ito yung na-calculate natin value ng reaction natin. So what we now do is to have yung cut sections natin. Okay? So, pero dito kailangan ay i-draw ko ulit yung free body diagram natin kasi kailangan natin pakita yung cut section natin. Okay? So, let me draw lang muna. Okay, this will be yung beam natin. And then, yung identified reactions natin. So, ito yung RA natin. 11.25 kilonewton. Ito yung RAX natin, which is 0. And then, we have RBY of 13.75 kilonewton. Okay? And then, we have yung applied reactions natin. So, we have here. Okay, so 10 kilonewton, then 15 kilonewton. So, ang assumption ko is, halimbawa, i-take natin yung internal force at point C. Okay? So, yan yung pinapahanap ngayon sa problem. So, 1.5 meters lahat yung distances niya. So, ibig sabihin, dito tayo sa point C, magpa-pass through ng section. Okay? So, ayan yung section natin. Sinabi mag-pass through tayo ng section. Ngayon, consider natin ang both left and right side. Okay? So, for the left side, ito yung left ng portion natin, ito yung right. So left side muna tayo. Okay, so left side. Okay, so ang gagawin nyo lang, i-drawing nyo lang yung left side. I-isolate nyo yung left side. Ito sabihin. Okay, then ito yung section natin. Okay, then we have yung reactions natin. Kung ano lahat yung nakikita nyo dun sa left side, no? And then ito, we have yung 10 kilonewtons. Then we have distances na 1.5, 1.5. Okay? Ngayon, dito sa cut section natin, kailangan i-expose natin yung internal forces natin. Ngayon, again, yung positive sense natin ng N ay tensile. For shear, dapat magkakos siya ng clockwise rotation. So, yung clockwise rotation ng ano natin will be ito. Okay, ito yung shear natin. And then yung moment natin, dapat tendency niya is to yan, mag-curve ng ganyan yung beam natin. Okay? So, let's draw yung ating moment. Yan. So yan. So yan na yung mismong structure natin. So as you can see, dire-draw lang natin itong side na to. Okay? Now we can now perform yung ating solution. So yung gagamitin lang din natin is yung equilibrium equations natin. So for normal force, summation of Fx lang tayo is equals to 0, taking to the right as positive. Okay? So dito, alin ba mga horizontal forces natin? We have yung 0 and then we have yung n. So we have 0 plus n is equals to 0 or n is equals to 0. Meaning 0 um, yung ating actual force. Okay? Next. Summation of forces y is equals to 0, taking upward as positive. Okay? So, upward direction natin is itong support natin and then dito meron tayong 10 and meron tayong V. Okay? So, we have 11.25 kilonewton. So, hindi ko nalagay yung unit. Minus 10. Then minus V is equals to 0. Performing yung calculation, V is equals to 1.25 kilonewton. Okay? So, ibig sabihin ito yung value daw ng mismong internal shear natin na V. Okay? And then for moment, okay? So, ang summation ng moment natin laging papunta dun sa point ng cut section natin. So, tawagin kong point C yung section na yon. So, doon tayo magmo-moment. No? Ibig sabihin, lahat ng forces natin, lahat magmo-moment dito sa point na to. And ano ba yung mga magro-rotate? Si horizontal, 0, wala naman yan. Si horizontal, since nandun sa point, hindi siya magro-rotate. Ito si vertical dito, nandun yung sa point na yun, so hindi siya magro-rotate. Ang magro-rotate lang is 10, pag ganun yung rotation niya. Si 11, pag ganun yung rotation. And then si M, pag ganun yung rotation. Okay? So, summation of moment at C is equals to 0. So, again, depende sa inyo kung ano yung assumption nyo. So, assume natin bawa clockwise as positive. Okay? So, clockwise natin is 11.25 times 3 minus 10 times 1.5. And then yung moment natin, since siya ay counterclockwise, minus M is equals to 0. We're calculating, we have M. So, 11.25 times 3 minus 10 times 1.5 is equals to 18.75 kilonewton meter. Okay? So, this will be our answer for internal moment. Okay? Ayan. So, if you're sure na tama lahat yung ginawa natin na procedure, that will be your answer. Pero if you want to check if that is the case or that is really the answer, you need to check the other side or the other section or yung other face ng section natin, which is itong side na to. Okay? And we will do that next. Okay? So, let me, yan. So, copy ko lang yung ating free body diagram ng full beam. Para ito yung consideration natin for the next slide. Okay? So, ito yan. Yan. And then, ang focus natin ngayon is yung ating right side naman tayo. Okay? So, now we consider yung right side ng portion natin. So, let me draw the beam. So, we have here yung rest ng beam natin. Nandito sa side na to, dito yung ating yung cut section natin. Okay? So, we have a reaction dito. And then, meron tayong, okay? So, this is 15 kilonewton. Then, this is 13.75 kilonewton. Then, our distances are 1.5 and 1.5. Okay? Ngayon, nandito yung exposed area natin. Okay? So, yung pagsulat ng ating internal forces, again, dapat positive siya kapag away siya dun sa body. And then kapag shear, dapat mag-clockwise siya. So, anong direction para mag-clockwise yung direction? Yung ating ikot. So, dapat siya ay upward. Okay? So, ito yung N natin, ito yung B. And then kailangan, dun sa moment, kailangan i-gaganyan niya yung ano, okay? I-bend niya doon sa direction na yon. So, kailangan, yung ating moment is pag ganyan. Okay? Yan na yung bago nating free body diagram for the right side. So, perform lang natin. Summation of Fx equals to 0. So, Fx, so ang horizontal force lang natin is nag-iisa, si N lang. Okay? Halimbawa, taking to the left as positive. So, N is equals to 0. So, yun agad yung value natin for normal force. Next, summation of Fy is equals to 0. Lahat ng vertical. So, vertical natin is V, tsaka itong dalawa. So, we have V minus 15 plus 13.75 equals to 0. So, that will be V minus 1.25 is equals to 0, or V is equals to 1.25 kilonewton. Okay? So, that is our value for V. Okay? Then next is, i-moment lang din natin ulit ito sa position ng cut natin. So, at C. So, summation of moment at C is equals to 0. So, assumption ko is taking clockwise as positive. Okay? So, alin na magro-rotate? Si V tsaka si N is at that point, so wala silang rotation. Si M is will rotate kasi moment yan. Ito magro-rotate papunta doon, and ito magro-rotate papunta doon. So, we have si M will be positive, then plus 15 times 1.5 minus 13.75 times 3 is equals to 0. Okay? So, M natin will be equals to 15 times 1.5 minus 13.75 times 3. It will be negative 18.75 kilonewton. Okay. Now, negative yung nakuha nating value. Ibig sabihin, yung assumption natin na pag ganun yung direction niya, na clockwise yung direction niya, is mali. Okay? So, ibig sabihin, itong portion na to, gagawin natin, dapat, yeah. So, dapat, M natin will be equals to 18.75 kilonewtons, and yung direction natin is counterclockwise. Okay? So, that will be our answer. Okay? So, to check if that's the same do sa previous one, tingnan lang natin. So, we have 0, 1.25, tsaka 18.75. Dito, 0, which is the same. 1.25, the same. And then yung value ng moment is positive 18.75. Kasi yung assumption natin dito is counterclockwise na siya. So, the same siya dito sa assumption natin dito. Okay? Right? So, that's for number 1. Kaya yung hanapin yung internal forces natin. Okay? Next, we go do sa previous number 2 natin. Again, The value of the reactions are already identified. Ngayon is i-draw lang natin ulit yung free body diagram natin. Okay? So we have our beam. Okay? So yung reactions natin dito sa end, lagay na lang natin. So 0 and then 1,800 Newton. Then we have 1,800 Newton meter. Okay. Then we have a loading, okay, of 1,200 Newton meter. Okay. Total length is the same. And then ang consideration natin is point C ulit. Okay. So 1.5 and 1.5. So si point A, si point B. Okay. So ang consider natin again is point C. Okay. So to calculate, once you identified na yung support reactions natin, and is mamili kayo kung left or right. So left side tayo muna. Okay? Pero in calculation, bawas exam, you can choose na isang side lang. Okay? So drawing yung left side natin, we have ito yung beam natin. Okay? And then, ang mangyayari, ito yung portion natin, cut portion natin. And then yung mangyayari sa ano natin, loading natin, magiging siyang trapezoidal, no? Sorry. Okay, na-discuss natin yan. Ito, we have dito 1,800. Meron siyang 0. And then meron siyang moment na 1,800 Newton meter. Okay? Then, ano mangyayari dito sa at point C? So, expose natin. So, tensile. Then, magkakos ng rotation na clockwise yung B natin. And then, yung moment natin, magkakos ng ganitong rotation. Okay? Again, assumptions lang yan. So, meron tayong loading na trapezoidal. Okay? Di ba ang ginagawa natin, kino-convert natin siya into ECL. So, kailangan i-convert natin sa ECL yung trapezoidal. And ang di ba nabanggit ko before, kailangan pag trapezoidal para mas madali, pag hiwalay natin o i-combine natin ang rectangle tsaka triangle. Okay? So, kailangan natin mahanap kung ano yung ang value nitong y na to. Okay? Yung height ng rectangle natin. Balikan natin yung mismong triangle natin and i-isolate natin dito yung triangle. Okay? And to identify yon, we can use ratio and proportion. So ito, ang height niya is 1,200. Ito ay y. Ito alam natin ang total distance ay 3. As ang distance nitong is 1.5. So by ratio and proportion, y is equals to 1.5 as 1 to over 3. So, makukuha natin y is equals to 600 Newton meter. Okay? So, ibig sabihin, ito yun. Ang value ng point na yun ay 600 Newton meter. Okay? So, kung 600 yun, magkano to ngayon kung natitira? Okay? Yung natitira will be 1,200 minus 600. That will be 600 Newton meter na lang. Okay? Then, we perform yung ECL natin. Okay? For the rectangle, ECL natin again is area. So, base times height lang. So, 600 times magkano? 1.5. Okay? We have 900. Then, yung ECL ng ating triangle is 1/2 600 times 1.5. That will be 450. So, saan yan? So, si rectangle dito mag-a-act sa gitna niya. And si triangle is dito sa location na to. Okay? 450. Okay? And na-identify natin yung distances ng mga ECL natin dun sa cut section natin. Okay? So ito, since rectangle yan, so half nung 1.5, 0.75 yan. And then ito, ano to? Di ba yan ay magiging 2/3 over L? 2/3 ng L. That will be 2/3 times yung 1.5 natin. That will be 3/3. So, sorry. So that will be 2/3 of L. Okay? 1.0. Okay? So now na okay na yung free body diagram ng left side natin, we can now perform yung ating summation of forces x equals to 0 para doon sa normal force. Normal force natin, taking to the right as positive, we have 0 plus n is equals to 0 or n is equals to 0. Okay? That will be our first value. Then for y, summation of forces y is equals to 0. Taking upward as positive, ang mga y natin are 1/8, itong 450, itong 900, tsaka si v. Okay? So we have 1,800 minus 450 minus 900 minus v is equals to 0 or v is equals to 1/8 minus 450 minus 900. That is 450. 450 unit natin is Newton. Okay? So that is our internal shear value. Then last, summation of moment at C is equals to 0. So lahat is imo-moment natin dito sa point na to. So that is our point C. Okay, taking counterclockwise as positive gagawin ko. Okay? So we have, magmo-moment sa kanya is si 1,800 papunta doon, si 1.8, si 450, si 900, and then dito si moment, M. Okay, so we have 1,800 minus 1.8, ito yung vertical reaction natin, times yung natin is 1.5. Okay, then plus 450 times 1.0 plus 900 times 0.75, and then counterclockwise si M is equals to 0. So calculate natin, we have 1.8 minus 1.8 times 1.5 plus 450 times 1 plus 900 times 0.75. We have a value of M is equals to 225 Newton meter. Okay, so Newton meter. Okay, so again, if you're sure na tama yung ginawa ninyo at this portion, this answer will be your answer for the internal forces. Okay, and one way to check it again is to also solve the other side uh, of the section. Okay, o yung left part. Okay, so let's perform din yung left part for demo. Okay, so this is our free body diagram. So ngayon, yung right side naman. So right side. Okay, so let me redraw yung free body diagram natin. But now we will focus dun sa ating right side. Okay, so this will be our value. Okay. Reaction, do we have reaction? So wala tayong reaction, external reaction, wala. Okay. So pag in-expose natin ngayon yung internal forces ito, so away, and then cos ng rotation na clockwise for V, okay? And then kailangan gumanto yung direction ng B. So para gumanon yung B, kailangan yung direction natin is pag ano. Okay? N, V, at M. Okay? So, ano lang yung unknown, ano lang yung known force natin? Itong point na to, which is dun sa cut natin kanina, dito, yung portion na yun is, ito yun, ito, sorry, itong portion na to, which is na-calculate natin as 600 Newton per meter. Okay, so this will be 600 Newton per meter. So, kunin lang natin yung ECL niya. We have a triangle, so 1/2 ng 600 times yung ano natin is 1.5. Okay? So, calculate natin 600 times 1.5 times 0.5, that is 450 Newton. Newton na lang. Okay? Kasi ECL na tayo. Okay, so 450 Newton. So, yung distance niya from our cut is ilan? 1/3 ng L. So, So, 1.5 yung length natin, divide natin ng 3, that is 0.5. Okay? So, now we can now perform summation of fx is equals to 0. So, taking, halimbawa, to the right, that's positive. So, we have, wala namang ibang choice, no? So, negative n is equals to 0. Dividing both side by negative, so n is equals to 0. Okay? Then, summation of fy is equals to 0, taking upward as positive. So, meron ba tayong upward? Wala. So, we have negative v, tapos minus 450 is equals to okay, wait lang. May problema pala dun sa ating assumption ng v, no? Mali yung nasulat ko. So, dapat magkokos ng clockwise rotation. Eh, ito is magkokos ng counterclockwise. So, let me edit this one. Okay, so this should be upward and then ito is okay? Yan. So now, ang positive direction natin will be V. V minus 450 is equals to 0 or V is equals to 450 newtons. Okay? And then last, summation of moment papunta kay C is equals to 0, taking clockwise as positive. So, si M will be clockwise, si 450 will be clockwise, kasi yung dalawang force are 0. So, we have M plus 450 times 0.5 is equals to 0, or M is equals to negative 225 Newton meter. Okay? Now, we can see na negative yung sign natin. Ibig sabihin, again, yung assumption natin na clockwise siya is incorrect. So, dapat siya ay counterclockwise. So, M natin is equals to 225 Newton meter. Tapos, ang ano natin is counterclockwise. Okay? So, checking dun sa ating left side, dapat ay 0, 450, 225. So, left side natin is 0. Okay, check. 450 is check. And then moment is 225. Na ang direction natin is counterclockwise. Okay? So, baka may question, bakit po yung sabi hindi chine-check kung positive or negative, no? Kasi yung sabi is identified siya na kapag positive siya dito, um, sabihin ito yung positive sense niya or assume mo dun sa part na yun is correct. Okay? So hindi mo na kailangan siyang ibalik kasi 'di ba kailangan opposite sila ng reaction. So kailangan kung para mag equal sila pag pinagdugtong na natin, kailangan magiging zero yung sum nila. Okay? Okay, right? So ayan. So yan yung sa example number 2 natin. Now we go dun sa last part natin. So we have itong third natin. So we have yung ito na mismo yung given. So ang gagawin natin is i-body diagram natin is i-drawing natin. Okay? So we have here our beam. Okay, and reaction natin or upward natin is 220 kilonewton. To the left natin is 0 and moment natin is 650 counterclockwise din yan. Okay? Okay, then we have our applied loadings. So we have here yung rectangular natin. Ito. Okay, then we have a downward force dito, then a moment. So 70 kilonewton, 150 kilonewton meter, and then we have 30. Okay? And then ang consider natin halimbawa is itong portion na to. Okay? So portion at C. So this will be our cut section. Okay? Makikita nyo dun sa previous example natin, mas madali yung right side na calculation kasi mas simple yung uh, ano natin, yung side na yun kasi wala nang reaction tapos loading lang yung mismong kinalculate natin. Ibig sabihin sa pag-calculate ng internal reaction or internal forces, pwede tayong mamili kung saan siya mas magiging simple. Okay? So dito, i-apply natin yun. Sa left at sa right, ito left side natin, ito yung reactions natin. Meron tayong rectangular, meron tayong tatlong reactions. Tapos sa right side, meron tayo nito. So, kung depende sa inyo, no, kung sa kayo mas madadalian, pero try natin right side lang yung kakalculate natin. So, right side tayo. Okay? So, i-redraw lang natin yung right side. So, we have, ito yung right side beam. Okay? Then, ito yung ating cut section. Then, yung ating loading is ito. Okay? So, ito will be papunta doon yung direction natin, away. And then, magta-tend na clockwise direction si V. And then, kailangan yung beam natin is mag-rotate papunta doon. So, ganun yung moment natin. And then, ano ba mga forces natin? So, we have a vertical force na 70 kilonewton. And then, we have a applied o point moment doon na 150 kilonewton meter. Okay? So, ang kulang na lang natin is itong ano natin. Ito is 30 kilonewton per meter. So, kunin natin yung ECL. So, 1/2 ng 30 times 2, yung length natin, is equals to 30 pa din. Pero Newton na siya. Okay? So, let's write that. Ito yung ECL. So, 30 kilonewton. Yung distance ng ECL, papunta kay C will be equals to 1/3 ng L natin. So, L natin is 2/3. So, 2/3 yung gagamitin natin value. Okay? Then, solve na natin since kompleto na naman. So, summation of forces X is equals to 0. Taking to the right as positive. So, negative N is equals to 0. So, N is equals to 0. Okay? Summation of Fy is equals to 0. So, Fy natin, lahat ng vertical natin is si V, si 30, si 70. Okay? So, we have, kunin natin upward as positive. So, V minus 30 minus 70 is equals to 0. So, V is equals to 100 kilonewton. Okay? So, this is our two external reactions na. And we have summation of moment at C is equals to 0. Taking clockwise as positive. Okay? So, ang clockwise natin are yung M, itong dalawa. And then, counterclockwise yung applied moment natin. So we have M plus 30 times 2/3 yung distance natin, plus 70 yung full length natin, minus 150 is equals to 0. So moment natin is equals to 30 times 2/3, okay, plus 70 times 2 minus 150. Our answer is actually ito ay minus 10 is equals to 0 or M is equals to 10 kilonewton. Mali. So ito is positive, dapat negative to. Negative 10 kilonewton meter. Okay? Meaning, yung assumption natin again, ito is incorrect. So dapat siya ay counterclockwise. Lagay natin counterclockwise. So this is our internal forces for the given beam. Okay? Again, to check if that is the answer, so all you need to do is to calculate yung left side and then verify kung ano yung makukuha yung value. If it's the same as this one, ibig sabihin tama yung calculation natin. Alright? So, I leave this to you na to try out yung left side so that ma-practice kayo. And then, I'll upload again or I will give, as I've said, the practice problem. So, 2 beams lang, identify nyo yung support reactions sa internal forces as your practice before the examination. All right? So at this point, this ends our lecture. If you have any question regarding the discussed topic, please don't hesitate to message me. Okay? So thank you guys and enjoy solving our examples.